What about inclusion in set theory? So we have two notations for inclusion. For example, if I have a set A, which contains three elements, which are A, B, or maybe it is preferred 1, 2. Let's start with numbers 1, 2, and 3. And the set B, which is the set 2, 3. So the cardinality of A is 3 because A contains 3 elements. The cardinality of B is 2. So if you want to denote that somebody is an element of A, one of the elements of A, 1 is inside A as an element. So A has 3 elements: the number 1, the number 2, and the number 3. The set B, we can view it as contained in A because its elements are also elements of A. We denote it by B is contained in A. So 1 belongs to A, also 2 belongs to A as an element, 3 belongs to A an element, and as an element. The set 2, 3 is contained in A, not as an element. We don't have here the element 2, 3. We don't have this element, but the elements of B are also elements of A. So B is contained in A. B is contained in A. So let me emphasize the set 2, 3 is a subset of A, but the set 2, 3 is not an element, is not one of the elements of A. It does not belong to A as an element. B is a subset of A, but B does not belong to A as an element. If I would take now a set C and define C to be, let's see, be defined as the set which contains the number 1 and the set 2, or maybe take another, I don't want C to intersect with A or B. So let's take C as the set which contains the number 5 and the set 2, 3. So C contains 2 elements. C contains 2 elements, the number 5 and the set 2, 3. C has 2 elements. One of them is a number and the other is a set. Here we can say that B is not contained in C because the elements of B are not here, but B as a whole, as a complex of which is a set of 2 numbers, B is an element of C. Here it is, the set B is, C has 2 elements, and one of the elements is the set B.